Hello, this is Dr. Lori Wilbur. Welcome to this discussion of what I call the research black box. I call it the research black box because for a lot of people, the whole entire research process is really a mystery. And before we get started talking about this research black box, I'd like to share a couple of things specifically about public health research that really help guide us. And those are the 10 essential services and the CPH exam content. As an overview, the 10 essential services are what public health believes they are able to deliver to the public consistently. They are essential. They are services that public health provides and ensures are happening for every community. The CPH exam content is designed to test whether a person who has completed a public health degree is ready to begin doing those things. And so they really go hand in hand, but they also really dovetail into exactly what we want to deliver to you for this P-Core class. First of all, we want you to be able to perform as a public health professional, i.e. the 10 essential services. Also, we would like for you to be able to pass examinations related to that content, and sometimes the testing for those kinds of topics are a little bit different than the actual doing, and so those two things really are two sides of the same sort of thing. So let's take a really quick look at the 10 essential services. And if you see here in the bottom right corner, what you'll notice is that the 10 essential public health services really fall into three different domains plus research. And so on the top right, we have assessment. In the bottom right, we have policy development. And in the left-hand side, we have assurance. As a foundation to all of those things, you'll see systems management and research. Research essentially being we want the things that we are providing to people, whether it's policies we're developing, whether it's providing care or assuring competent workforce or whatever it is, we want that to be evidence-based. We want it to be based on actual research where we've found certain ways of doing things that actually has the results that we think it's going to have. So it's really important as we're going through public health that we think about this from an evidence-based mindset. So that's one of the things. The other one has to do with the CPH content. And I've given you a link that takes you directly to this PDF. You can also search for it. Just search CPH Content Outline 2019. You can find it anytime you want. Right here at the beginning, we see evidence-based approaches to public health. And there are 14 numbered items. You can read through them. I'd like to highlight some of the things that we'll be doing this particular quarter and focusing in on the different mini lessons, on the integrated project. We start off by thinking about descriptive statistics, which really is number 4 here. Apply descriptive techniques commonly used to summarize public data. So descriptive means we're describing one variable at a time. We're not trying to make inferences about relationships between variables yet. We'll be doing that later. But applying these descriptive techniques fall into two different realms. We can make pictures, and we can also summarize data with numbers. And so that is where a lot of people start to get a little concerned about this P-Core experience. Is this going to be like a math class? And in some ways, it may seem like a little bit of math. Biostatistics is, for some people, a little bit scary topic. And what I'd like to assure you is that you are applying things and you're learning how to use this. Doesn't matter what field you are going into, whether you're focusing on policy or health education, you must know how to summarize data. You have to have these descriptive techniques, and I will be giving you some of the most basic ones, along with some of the other things on this list we'll be touching on. Specifically number 5, I like to call this what could possibly go wrong. So identify the limitations of research results or data sources or programs or practices. And so how could what we think we're doing right actually have some limitations for those kinds of research. We'll be using statistical packages, number 6. We will be interpreting results of analyses and interpreting data. We will not be doing number 3. We will not be focusing on inference except for getting a start on the conversation as it relates to some of this summarizing of data. And you can read through some of the rest of those on your own. This really gives you the why of all the different things that I'm showing you and asking you to complete and turn in. This really helps to support the direction of where we're going with this particular class. So let me share a little bit about this research black box. And the black box, again, because for a lot of people this is this giant mystery. It's like somehow somebody asks a question and out the other side of the box pops this answer, yes or no. And it's immutable, it's not changeable, you can't question it. But what I'd like to do is to take that mystery away and just show you some of the basic things that go into this research process. So first of all, we start by asking a question. A lot of times this question comes from someplace. Maybe somebody read a previous article, or they noticed something in their practice, or they were observing. All of a sudden there's this new thing that's happening, and I'm not sure why, but here I have this question. And so what happens after that is we design a study. So we design how are we going to find people to study, how are we going to ask questions, what kinds of things will we ask, what sort of variables do we need to collect. And then once we know that basic information, we go out into the field and we collect the data. Maybe it's at a clinic, maybe it's by gleaning information off of a website or a previously collected data. We use something that's already been collected before. And then once we have our data, we analyze it. In other words, we put it through this magic machine, and out the other side pops the result. Analyzing data falls into two main areas. We have descriptive statistics and inferential statistics. This quarter in the fall, we are really focusing heavily on this descriptive statistics, where we're really looking at one variable at a time. As soon as we're trying to infer relationships between variables, then that's two or more variables at a time. So we're really in the realm of just one variable at a time. Can we take a whole pile of numbers and summarize them in a way that somebody could understand them? So once we've done that summarizing, we need to interpret and maybe say what it is that we think that means. And often it also means to share those results that we have. And often just one study will prompt 2 or 3 more questions. And so you can see how this cycle just continues to go round and round and round. And so we're constantly asking questions and then finding an evidence-based way of answering that question. The other thing I'd like to share with you about the research process, some of you have actually done research and you know that it's not just a clean, we don't just neatly go around the cycle. Sometimes we ask a question and then when we get to the designing of the study, we realize maybe we need to rethink exactly how we're going to ask that question, or maybe we've designed the study and we start collecting the data and we need to go back to some previous level. So there's often this iterative cycling even within. And so we may say, well, we thought we needed a certain sample size, but then now that we've collected the data and done some preliminary analysis, we realize that this would be a much better study if we spent a little bit more time and collected more data. So it really does go round and round. The other thing that I like to add to this is this: what could possibly go wrong? And we'll be thinking about the limitations of how a lot of the things that we do really are limited in the way that we do them. Ideally, we would have a population of individuals and we would study absolutely everybody so we could know exactly what either the descriptive, how is this sample distributed for one variable at a time, or so that we can see the relationship for every single person in the population. Sometimes, and I would actually say often, studying every single person in a population is just impossible. We would spend 100 years collecting that much data, and half the people would die in that time frame, or everybody. And so what we really have to do often is take a sample of the population. In other words, we take just some of the individuals, we collect the data on just those individuals, and then we want to infer something back to the population. So the way that looks is here we start with our population, we take our sample, and then we measure something. I'm going to call this statistics. The statistic is related to the sample. And then we infer something back about the population parameters. And so at each of these places where there's an arrow, those are the places where something can go wrong. In other words, as we're drawing our sample from the population, what if we don't draw a very representative sample? What if we draw a sample that is older or healthier or sicker or more educated than the actual population that we're trying to represent? Sometimes this happens if there's a convenient way to find a sample of individuals. Say they're the ones that go to clinic, or they're the ones that are in school, or they're the ones that happen to be in the hospital. So there's this whole discussion around how did we find the sample that is supposed to represent the whole population. Once we have the sample, then we're going to measure something. And if you can imagine, if we measured something over and over and over again, we would actually not get exactly the same result each time. And sometimes that's dependent on how the person is measuring, how the person is using that particular instrument. I like to use the example, if we drew somebody's blood several different times and ran it through a machine, each time their cholesterol might be slightly higher or lower just based on the sample that we got from them. We can't take all of their blood out and send it through the machine to find out what their cholesterol or their blood sugar is. So we take this sample and we do a measurement just on that smaller sample, and even just the measuring process itself, if we were to send the same sample through the machine several times, we would sometimes end up with different numbers. And then in that process, and we'll learn all about this when we start talking about inference, is that we take those numbers that we got and then we infer back about the population parameters. So just that process also has some inherent problems or errors that could happen. So think about both the process of how we go around this circle, and then also the process of the actual statistical thinking, where we really want to be able to say something about a population, but we have to use a smaller group of individuals. So both of those things are important pieces of the research black box. I thank you for joining me, and I look forward to working with you in this course.